Hi, welcome to Lab 4. In this step, we are going to perform explainable machine learning using the DALX package. In step 3, we observed relatively high training and test model accuracy. We also observed an improved lane cover map. So in step 4, we are going to use explainable machine learning methods in order to gain insights into the model performance. Here, we are also going to calculate feature importance, compute and plot accumulated dependence profile, as well as calculate Shapley values and plot breakdown profiles. So first, we are going to use the explain function in order to create an explainer object that contains the explainer for the random forest model. So we are simply going to take the random forest model that we created in step 3. We are also going to use the training dataset that contains predictor variables such as Sentinel-2 spectral reflectance values and Sentinel-1 backscatter values. We are also going to take in the lane cover classes as the response variable. So if we run this chunk of code, we are going to create the explainer for this model. Right. So next we are going to use the model parts function, which takes in the explainer that we created in the first step. Right here we are going to produce the feature importance. Okay, so if we run this chunk of code, we produce our feature importance graph. Okay, so the feature importance graph shows the predictor variables and their contribution to the random forest model. So here we are interested in the 4 top important predictor variables. So the most important predictor variable here is Sentinel-2 band 2 from the rainy season. So this is followed by the Sentinel-1 VH from the dry season. Next, we have band 2 and band 12 from the post-rainy season. So we are going to use these top 4 predictor variables in order to check how they influence the prediction of each lane cover class. So if we run this chunk of code, we are going to produce the accumulated dependence profile graphs. So let's just expand this window and check the accumulated dependence profile. So here we can see that band 2 from the rain season has a positive influence in the prediction of here the built up class and also the Bay Areas class. Okay, so this is quite good. Uh, we can see also something very interesting here. For example, the Sentinel-1 VH from the dry season also has a positive influence for the prediction of the grass open areas. The same goes for the built up areas and the bare areas. We also have a relatively positive influence on the prediction of the woodland class. So this is quite important. And in addition, we can also observe something very interesting. That is here, we can easily separate the cropland and the grass open areas. So if we are using optical sensors, it is quite difficult to separate grass and cropland areas in this test site because they look similar. But here, the Sentinel-1 VH looks like it is separating these two classes very well. So this is quite positive. Right, next we want to check uh, how the Shapley values behave for a single pixel observation. For example, this pixel observation is located at 50. So if we run this code, we produce our Shapley values. Okay, so for that location, we can see that only 4 bands contribute to the prediction of the bare areas. Okay, for the built up areas, all these predictor variables contribute to the prediction of this class. So this is quite interesting because we have here VH from the post rainy season, VH from the dry season, and the other bands from Sentinel 2, rainy season, post rainy season, and even dry season. So this is quite informative. Right, for the cropland, we only have one band which contribute positively to the prediction of this class. For the grass open areas, all these bands contribute negatively to the prediction of this class. For water and woodlands, we only have two bands that contribute positively to the prediction of these classes. Right, next we can also check the breakdown profile for the same location, the location 50. So if we run this chunk of code, we produce the breakdown profile graph. Again, here we notice 4 bands which have a positive contribution to the prediction of the Bay areas. For the built up areas, we have all the predictor variables contributing to the prediction of this class. For water and woodlands, we only have only two bands as we have noticed with the Shapley values. Okay, so this is quite informative and interesting. So you can actually check the other pixel locations so that you get insights into the model. Right, so this is all about the data-centric explainable machine learning for lane cover classification. So if you want to learn more about these methods, please check out my book in the link below. Right, please also subscribe to my channel so that you get alerts when I have a new tutorial. Okay, thank you. Bye.